Hey QED Coders, this is Michael. I am getting ready for CodeLaunch LATAM, which is coming up in October. In fact, let me go ahead and share with you a little bit of these details. So it's going to be in Guadalajara on October 8th, so I mean that's coming up really fast. And I need to get LaunchKings ready for CodeLaunch LATAM. One of the things that's really exciting about this coincides with our new Latin American office in Guatemala. So we've actually partnered up with our old friends at Mango Chango. See these folks here. Curtis, he's the second one on the left there, and he's been longtime friends with the founders of Mango Chango, and so they've grown their business since 2019. Really, really ascribe to the same sorts of values that we do, with conscious capitalism, with excellence, with involvement and dedication to the community, and so this was a perfect time to bring them on board. And what used to be our CodeLaunch Mexico is now CodeLaunch Latin America. So we are growing in that space. But that means that I need to get some things ready. So I built LaunchKings, an attendee-focused application for CodeLaunch, and we first used it in Canada. And it was a raging success. It was a great demonstration of the power of an immutable architecture like Jinaga, and the attendees really enjoyed it. While everybody had a great time with it, I was looking at the logs scrolling on my screen while I'm sitting there at the event. It was a great time, and I did notice some things. I can't lie. There were some issues. Nobody was affected by those issues, at least that I know of. But we need to get some of those fixed. In addition to that, we've got some features that we're building into LaunchKings, so we need to get those added. So I figured I would take this opportunity while Jan is unfortunately away today to actually work on some of those fixes. I'll take you along for the journey. We can see what it's like to maintain and to build a Jinaga application. So let's transition back to our LaunchKings application as we've got it running locally. So I've set it up in Docker. So I've got my command line here where I've been looking at logs in Docker, seeing what I can resolve. We just fixed an Nginx issue. There was a static file where there was supposed to be a folder, and so rebuilt, remounted, everything's good there. So now we are about to set up tenants. So in every immutable architecture, in every historical model, there is going to be a multi-tenant application. That's the way that it works from the ground up, and that's really because you cannot say, I want to see every customer in the database. What is the database? The database is just one replica of many replicas. Could be all around the world. We don't constrain that, and we don't know that while we're working with one application. This one application has access to this one replica, and so we have to know that we are authorized, that we are able to see these particular customers. So it can't just be all customers in the database. It has to be all customers within something, a tenant. And so the replication system and the authorization and distribution system forces you to have a multi-tenant database, which is not a bad thing. So that means here I've set up a brand new replica, and I need to create a tenant. So what actually is a tenant? Well, I'll create one, and we can see that it just called save, and it saved a thing. Well, here's the payload of what it just saved. So this is a really useful format that I've built into Jinaga, and I'm going to be relying upon this format for more things. But it's a little bit unusual if you're used to looking at JSON going back and forth. So this is the Jinaga fact stream format. So you can see from the content type or graph, application X Jinaga graph version 1. And so this is a way that you can stream an entire graph between two nodes. It's intended to be used in both directions. Right now it's only used on save, but yeah, I'm going to be updating the feeds so that they will give you back graphs as well. So we've got a way to send private key or public keys. So here's a public key. I called it PK0. You don't yet know how it's used. And then I'm going to send you a fact. Here's the fact type. It's a Jinaga user. It has no predecessors, so that's the predecessors collection. And then it's got a single field called public key, and there's the public key. It just so happens that's the same public key as this. But there's no reason that it would have to be. This is just a fact that I'm sending you. Now here is a signature. So I'm saying there is a particular user that created this fact, and that user has public key PK0. And so if you were to use this public key, you could validate this signature against this content, and you would know it came from that user. And that is going to allow replicators to replicate with each other when the user is no longer around. So the user has signed their facts, and now the replicators can share those facts, trusting that it came from the original user that it was supposed to. So that's all good, and then we send in another Jinaga user. So this is a different public key. And actually, now that I think about it, I'm not sure which of these two public keys represents this one. We would have to investigate a little bit further. I see /r/n2z /r/n, yeah, 2z. It's actually the second one that's that user. And so then here is the signature from that user as well. What's all this? Why do I have these two user facts signed by one user but two separate users? I don't know. Let's see. Well, here we say we've got a CodeLaunch tenant fact, and it has one predecessor, creator, and that creator is fact number 1. So not 0, but 1. So it just keeps track of the index, and it says, okay, that was fact number 1 in this graph, in this stream. That's not a global ID. That's not a unique ID. That's not an ID in the database or in the world. It's just within this stream. So that was the creator, and I've signed this tenant with PK0. So here's the signature for the tenant created by this user. So what that is telling me is that I've now, I can trust that this tenant has an owner, and I know who that owner is. I still don't know exactly what I want to do with it. And so that's why the next fact comes along. It's a CodeLaunch tenant administrator, which now tells us that the tenant predecessor, number 2, this one, and it has a user predecessor, 0. So that's this one. And we say that we're going to sign with PK0, and here is the signature. Zoop. And that is the end of the stream. So I've just sent you a little bitty graph. 2 users, a tenant created by one of those users, and an administrator that says the other user is an administrator of that tenant. What just happened here is that we had a single use user. The public key right here is the public key of the single use user. This right here is that single use user. So this was created client-side. The private key for this public key was known client-side. And then it was used to create this tenant fact and this administrator fact. So it says, here's a brand new tenant, and this logged in user is the administrator. After that, the private key was destroyed, so this little graph is the only thing that creator will ever do. But now that the logged in user, me, is an administrator of that tenant, now I'm authorized to do other things. So that's what happened right there. And all of that is shared via this little payload. Now, what does all that do for me? Well, now I've got this public key, or this tenant ID, which is really the public key of the user that created it. And now I'm going to configure my application so that it uses that tenant in order to do things like load all the events. If I go to all events right now, I can say, hey, you need to set up your tenant public key. So go to tenants to get started. Well, there, we were just there. So I've got that in the clipboard. I'm going to go to my setup folder, or my scripts folder. There we go. And I am going to follow this little README right here that tells me that I need to npm run update tenant key with that tenant public key. So npm run update tenant key, and here's the tenant key. Paste that in. All right, and now that little script could not read package JSON. Why can we not read package JSON? I thought we were, well, we're supposed to be in setup. Setup. Now run it. Okay. There we go. So this looks for some files, some configuration files where it needs to update the tenant key. Writes the files. Okay. Perfect. All those files are written. Now we need to restart the stack. So let's copy that command right there. And in fact, I need to come back up here, and now I can cd to mesh. I docker compose down, docker compose up, disconnected. That not only restarts but rebuilds all of the containers. And those containers that are mounted to a file still remain mounted to, or to a folder, still remain mounted to those folders, so they have volumes. Anyway, all of that is restarted, and so that rebuilding the container was necessary because we changed the configuration that's used in the docker compose, and so it brought that configuration into the containers definition. So we now have our tenant public key. If that worked correctly, I should be able to, let's go ahead and clear this out, rebuild this. Okay, I'm still logged in. I can still see the tenant. And now if I go to all events, it still says I need to set the Veep tenant public key. Okay, that's because one of the files that it changed was the .env.container.local inside of LaunchKings admin. And this gets built into the JavaScript bundle. Now, restarting the Docker containers and rebuilding the Docker containers doesn't rebuild the JavaScript bundles, so I need to do that. Let's go to app and LaunchKings admin and npm run build container. So that builds the bundle, which now pulls in that that tenant ID. And so if I do that, now when I restart or refresh, it's got the tenant ID. And saying, okay, I've got no feeds for this tenant. Looking good so far. Or no events for this tenant. I said feeds because I'm looking at all these feeds. Now you can let me give you a quick view of what is currently happening with feeds. So so here we've got a feed. I want to get all of the facts that are necessary to run this specification. So given a CodeLaunch tenant P1 and a Jinaga user P2, give me all of the administrators U1 such that U1's tenant is P1 and U1's user is P2. Basically, I am this user. I'm trying to access this tenant. Am I an administrator? That's what that's asking. There are other questions here that it's asking. Given a tenant, give me all of the events, and then for each event, give me their names, where there does not exist a new name that's replaced it. So give me all the names for that. Here, give me all of the. That looks like it's the same feed. So this might have been, yeah, before refresh and after refresh. That's what I'm guessing. Yeah. That's right, yeah, it wouldn't have been able to run this one because it didn't know what the tenant was, but now it does. There's the hash of the tenant. And then what it gets back from those, the response, is a set of feeds. So here's a feed. Here are 3 feeds. It's going to take 3 feeds in order to satisfy this specification. We can see here, same 3 feeds. It was the same specification. So now we've got these 4 feeds that we need to pay attention to. We need to load. So hit the feed, and we say our bookmark is currently empty, so we're starting at the beginning of the feed, and then we get back a response. The response is, I got nothing for you. You're still at the bookmark empty. For some of these feeds, like this one here, the response is, okay, I've got a CodeLaunch tenant administrator. Here's the hash of that administrator, and now you're at bookmark 5. And so it needs to loop back around and call load after it fetches a whole bunch of, like here's, yeah. So here it's saying I want to load, here's the payload. I want to load the facts for that particular reference. So that's the only reference that it doesn't know about. Let me load them in. And so here is the response. Here are your facts. Type Jinaga user hash. Here's the fields. Here are the predecessors. So wait a minute. Didn't we have a different format for this? One that was a bit more compact? Why, yes, we did. So this is one of the upcoming Jinaga features, is I'm going to replace this with, we don't have our save anymore, with the format that save was demonstrating, with the Jinaga graph format. So it'll be much more compact. So we send back not just the administrator fact that you asked for, but all of its predecessors. Here's everything that you need to know in order to understand what you're an administrator of. So now we've got that in our local replica, and we can run that specification locally in order to see what is happening. And that gets mapped to the user interface. Okay, so let's drag that down a little bit. We'll keep it open because something interesting might pop up. Now we need to create an event. So let's go ahead and say that we are setting up for CodeLaunch LATAM. Create that. All right. Now we should have a save. This save says, here's the payload, that this particular user is the creator of this particular tenant, and there's this CodeLaunch event within that tenant. And the name of that event is CodeLaunch LATAM. And we're going to go ahead and start the voting round 1 and voting round 2. Those two things right there are actually because of a race condition that I found in LaunchKings, and so I had to pre-initialize those two voting rounds. Once I fix that race condition, and that's a race condition deep inside of Jinaga itself. Once I fix that race condition, I won't need to pre-seed these voting rounds. It'll be really cool. But for right now, that is necessary. So there's the little graph that just means I want to save an event. And you can see there are no signatures here. There's no public key shared. Why is that? Well, that's because in this particular request, I have a bearer token. So that means the replicator that I'm talking to can validate that token, know which user I am, and it will sign all those facts for me. So the private key for the logged in user doesn't have to be on the client. It's only the private key for that one-time principal that we saw before. So we've just created an event. Perfect. Now we can edit that event, change the name if we wanted to, or we could jump in here and set it up. So we've got finalists. And we'll talk about the attendee access code in a minute. So let's see what finalists we want to set up. We have, well, I know the finalists have been announced. Here are the Professional Coder League teams. That's cool. Yeah, not sure if we are showing the finalists on this page yet. Okay. Well, so here is, yeah. So I would have to find that that edition of the newsletter that has the announcements. But for right now, let's go ahead and set up. Here we go. No, there we are. Let's set up some some simple finalist names here. So we got A and B. I know, doing all the boring things. Yeah, in some cases I did things like cartoon dogs. So I had Astro and Bluey, and let's see, I did Clifford, and yeah, it was. Yeah, I think I used Scooby-Doo for D. No, wait, Dino. Dino is a cartoon dog, even though he's a dinosaur. Okay, so we've got some finalists in there, and you could see that while I was doing that, it's doing a whole bunch of save. Sending them all to the server. So here's the payload for each one of those. Here's a competitor within the tenant. Here's the event, and now we've got the competitor logo and the competitor name and the fact that this competitor is a finalist at this event. So that's the relationship between the two. Send them all up. Do that again and again and again. Now we've got these competitors. All right, so the first feature, in fact, we'll save the attendee access codes, see if we do get time for those. But the first feature that I wanted to add was the fact that right here, if you're looking at all the events, when you go to the actual LaunchKings admin site on the web, you see a whole bunch of events that were created for testing and for demonstrations and all sorts of things. And we need to clean that up. So we need some sort of a delete mechanism. So how am I going to accomplish that? Well, as it happens, I've already gotten things started on one of my branches. So I'm going to come back here and take a look at all my branches. So locally, I just have main, keeping things nice and clean here. Git branch -- all. And remote, I've got a few more, not keeping it in quite as clean remotely. Probably should clean it up. But one of those is delete event. So let's check that out. Git checkout delete event. Okay, so that set that one up locally, and now I'm tracking it, and now I can take a look at the git log, and I can see that I've written up a delete and restore specification. I've modeled the event deletion and restore, and this is right here where the main branch starts. So if I do a git LGA, I should be able to see, here's main. Oh, main does have one commit beyond. So that's where we diverge from main, just these two. So event deletion and restore. What does that mean? Let's do actually, we can just look at the graph right over here. Come over here, we see the graph. Okay, delete and restore. If I take a look at the CodeLaunch file, I have a new fact type, event delete and event restore. I've deleted some things, like here I wasn't using the in function. Here I wasn't using the users of function anymore. I can talk about why. And here I've set up event delete and event restore. So let's pop over to that file, and we can take a look at these a little bit more closely. Let's go back up to event. So this is how we define a fact in Jinaga.js. It's got a type, so that is a string that includes the full namespace of what I'm trying to build, and that type, as we saw in the messages going back and forth, that's really all that it uses in order to indicate what type of fact it is we're talking about. And then we've got, whereas this one is a static, this one is an instance property. So each fact has the type associated with it. The constructor here, we've set up the tenant, which is another fact, as a predecessor. And here we've set the ID of the event as a field. So predecessors and fields are constructor parameters, and so the JavaScript object that you get has type, tenant, and ID. Just 3 fields. That's it. Here's a static helper method that will give us all of the events in a tenant. So when this is written out and it's used, it reads nicely, the event.in tenant. Well, what that is going to do is find all of the successors of the tenant of type event, and it'll link that event up to the tenant using that tenant predecessor. So that's how it knows what the successor means. And then it's going to filter that. I just want the ones where there does not exist an event delete, and I only want to include event delete where there does not exist an event restore. And so that is going to filter deleted events out of the list of events in a tenant. So this screen right here is running that specification. Unfortunately, this screen does not have a way to create a delete. So we need to be able to create an event delete fact. So an event delete will be, I've deleted this event at a specific time. And then event restore means that I have undone this event delete. So they're just pointing back up to their predecessors. And that's what allows me to write a specification that works like this. So the intent is when I push the delete button, this disappears. And then I should be able to find a list of all deleted events and push another button on that to bring it back. And that will be event delete would be the first button, event restore would be the second button. That simple. Now, how are we going to accomplish that? Well, here is the delete and restore UI. So let's go to that file. So I want to event delete and restore. There it is. Okay, there's the actual file. Now I can preview the markdown. And so this is the plan that that I developed using an LLM in order to add this user interface to the application. So, step 1, delete button in the event list. So we've got an event button. Then 1.1 or 1.2, delete action with snack bar notification. So you hit the delete button and it shows a little snack bar. It says this event has been deleted. You can restore it anytime. Nice and safe. And then we've got our event details page, delete action. And this delete action, this looks like it is trying to do, let's see, we've already, oh, that's the snack bar action, sorry. Yeah, this list item has the button. I don't know why we need this. Handle delete event already shows up here. Yeah, we don't need that. So let's get rid of that. Event details page, delete action. That makes no sense. Just bam. Then deleted events management interface, events drop down. So we've got our deleted events in the drop down. It shows up under all events. We've got deleted events. That's the new one. So right down here. And then we have a list page for it, and we handle bulk restore. Interesting. Okay. So it looks like we might have checkboxes on them. Yeah, that's probably a good idea. Now we've got handle restore event, handle view event. So we can view the event that's been deleted. I don't know if we need to do that. I guess if two events have the same name, you wouldn't know which one is which, so you might want to view it. Yeah, so restore action with a snack bar. It says it has been restored. Now, do our snack bar component because we are working within a design system. That's good. New hooks and services. Okay, this is where we get into the Jinaga integration. So use deleted events and use event deletion. So model integration, deleted events in tenant, query for events with event delete but with no event restore. Perfect. That will get you deleted events in tenant. Event deletion history, query for complete deletion restoration history. Nah, we don't need that. Boom. So, no, I don't need it. Delete event. Create a delete event fact. Restore event. Create a restore event fact. Perfect. All right. So the user clicks the delete button on the event. The event is immediately deleted from the main list. Snack bar appears, and the user can click the link to view deleted events or continue working. Restoration flow, the user navigates to deleted events. The user identifies the event to restore. User clicks the restore button. Okay, well, if we've got a restore button, then we don't have a bulk restore. This is one that that I think is worthy of reprompting. So we're going back to roux. In fact, I actually prefer now to use kilo code, which is a fork of roux, but I haven't set it up on this machine yet, so we'll just use roux, which is still set up here. So, yeah. Let's see. Review the event deletion UI recommendations. let's see, we are in code. I want to be in plan and design before implementation. I want to be an architect. To learn about event deletion and restore. The plan to implement event deletion and restore. So this plan includes bulk delete. Yeah, this plan includes bulk delete. It should only perform single delete. So let's see if it's going to consistently update the plan so that we can just do that. User wants me to review this document. Explore the project structure. Oh, it's gonna just go into the whole project architecture, not just focus on the document. Well, now I've reviewed the document and identified several areas where bulk operations are included. Before I create a revised plan that removes bulk operations, it focuses on single delete operations. I'd like to clarify the scope of the changes needed. Should I remove all bulk operations, keep only single delete functionality throughout the entire document? Remove them, but mention as future enhancement. Focus only on MVP. Yeah, I don't even want them in future phases. Get it out of your context. Okay, there's my to-do list. So, lots of things that I need to do in order to update this document. So keep track of them, do them one by one. So it's going to search all directories for bulk operations. That might be going a bit too far. But we will see when we take a look at the git diff if it went too far. Okay, so delete the example. Oh, it checked off a whole bunch of things. So validate the revised document. Now let's look for bulk again. Excellent. It's not there, boss. Okay, let's see what kind of bone this dog has brought me. Is this the bone that I want? So we've got changes in okay, so this was a document that described an Nginx fix that I just did. I don't need to keep that file. Here's the one that we're doing right now. Okay, so we got rid of event details page delete action. So add a delete event button, and here's the visual design. It doesn't seem like we should have gotten rid of that. So let's come back to the top here. So delete button in event list. Okay, yeah, that is okay. Yep, that is precisely what we wanted to get rid of. Oh yeah, I deleted that part. Yeah, it's like, no, there's not an action button. It's per item. Okay, so then we don't have a bulk restoration option. We don't have a restore selected button in the header. That's all good. And we don't have event deletion history. I deleted that one. And then here, we don't have bulk actions at all. And then we just renumber things. And okay, that was a good set of changes. So remove, bulk, restore. All right. Now let's see what does the rest of the plan look like? I think we are in a good place to implement this plan. So I'm just going to start it from the top and see what we can do. So the plan is already broken down into different steps, and as it happens, root, starting a brand new context so that it doesn't see any of those things that we just deleted, root has this nice little orchestrator mode which works in task breakdown. So with this, I can give it an entire phase, so the event deletion interface, and it'll break it down and it'll do these tasks one by one. In fact, I might even be able to give it more. So 2 is a pretty solid set of things. Snack bar components, I think that's solid. Hooks, let's go ahead and give it 1, 2, and 3. So we're going to be right here. Close all these others. Implement phases 1, 2, and 3 of event deletion UI recommendations. And now it's got all the information that it needs in that document. We've constrained it to 1, 2, and 3. It's a complex multi-step process. Well, it's a good thing you're in orchestrator mode. So now here's your to-do list that you just built from the structure of the document. And you're going to delegate to subtasks. Here we go. So let's take a look at our current user interface. Let's identify the patterns and provide a comprehensive plan. So we've asked the architect to take a look at the React. So the architect is reacting to the React. And it's looking at atoms, molecules, and organisms. Okay, so it sees, hey, you were using the atomic design principles to build a design system. I should work within those constraints. Okay, want to understand the event context and the navigation structure. It's off to a good start. Now, while it's working, I can pop over here and we can see that this project I started setting it up for cursor. So right now I only have one cursor rule in here. But if I were to do this in cursor, I would want to add additional rules that represent the sorts of tasks that it might be performing. So this is a rule that I developed along with the LLM after we completed a Jinaga modeling task. And so it documented these are the things you should think about when you're writing a Jinaga model. Have these static methods that help you out. This is what a fact looks like. This is how you would add that fact to the model. And then it gets into authorization rules, which is also something that I've already taken care of. So we can take a look at the authorization rules while it's working, see what that looks like. But as you can see so far with cursor, I've just got this one rule. What I would do if I were in cursor is, as we are working through these tasks here, I would have a little retrospective at the end of each miniature little task and say, summarize what you just learned. And I would write a little summary. Then I would kind of pick it apart, say, no, not that. Yeah, include this, focus on that. And then once we've got the summary how I like it, I would say, then write that to an MDC file. And it would write the rule. And then I would review the rule. I would edit it. And then that's available for me to use in the future. All right, we've moved on from that subtask. We're back to the orchestrator. It's creating another subtask in order to to review and update the Jinaga data model for event deletion and restore functionality. It should find that the data model is all up to date. No changes necessary there. I see event delete, I see event restore. Let's examine the authorization rules next. Great idea. Let's examine those next. And notice that the distribution rules don't include event delete and restore, right? I don't like to write distribution rules until I use them, but maybe that is some guidance that I need to give the LLM so that it shares that opinion. So distribution rules are missing. No specifications for recurring deleted events. Right, yes. You don't write them until you need them. But here it goes, writing them anyway. All right. Well, we will let it continue to work in the order that it decided to work in, see if it gets it right. But order matters with LLMs. You want to give the LLM the most constrained task first. So here it's writing a distribution rule for a specification that doesn't yet exist, and now it's writing a specification for a user interface that doesn't yet exist. Then when we get to that user interface, the specification might be wrong, or we run that specification and the distribution rule might be wrong. So there's no constraints on the distribution rule at the very beginning. There are constraints on the user interface. We want the user interface to work according to this specification. So build the user interface first. And then that applies constraints to the specification, which then applies constraints to the distribution rule. So you need to give it the opinion to work in that order, which I have failed to do, so it's working in the wrong order. You can see here I've got a root folder and a kilocode folder. So there's also down here a root modes and a kilocode modes file. These are the places where I would put what in Cursor would be cursor rules. I would create those modes. So far I've just got a project manager that uses the Azure DevOps MCP server in order to create user stories. So that's pretty fun. I like to use that in order to manage things. But then you also have, let's see, so that was the kilo modes, because I was using kilocode to do that. In root modes, this is where I put the equivalent of the Jinaga modeler rule that I created in Cursor. So yeah, that's one of the downsides of playing around with all of the tools all the time, is that I end up rebuilding rules in different tools. All right, so we want to check out the authorization rules. How is it doing so far? So the code mode has completed the snack bar component. Okay. All right, we'll come back and take a look at that in a little bit. But let's take a look at the authorization rules. So let's come back here. This is our CodeLaunch model. I have here an authorization folder, which has the different authorization rules for the different parts of the model. So here is the competition authorization, the competitor authorization, event authorization. This would be the one. So here I've created these little authorization rules. Who is allowed to create events? Who is allowed to change their name? Who's allowed to set the date? Who's allowed to create those attendee access paths that we haven't looked at yet, but those are the QR codes. Who's allowed to change the event state? Who's allowed to delete them? And who's allowed to restore them? So these are the two new authorization rules. And you can see, well, who is allowed to? It's the administrator users of the tenant. So walk up that graph till you get to the tenant, and then look for all of the administrators. Coming back here. I need to double click it to keep it open. Event authorization. There we go. So what do we mean by administrator users of? So we start with a tenant, and that's a label of type tenant, which means that it's inside of a specification. It's not an actual tenant fact. It's the label that is in that specification. So now I can look at the tenant successors. Yeah, there it is. Of type administrator. Now that administrator points to that tenant, so that's how I can find them. And then from those, I select the user predecessor. So to remind you what that looks like, an administrator points to a tenant and to a user and says, this user is an administrator of that tenant. And it was created at a certain time. So that's what that is saying. I don't yet have, as you can see here, I don't yet have a fact to revoke administrator privileges. That seems like that would be a good addition to make at this juncture. So yeah, let's. Yeah, not going to have time to do that today, but that is now something on the list. All right, Rue is very, very busy. Is it making good progress? I do not know. Need to update the events TSX file to use the delete event method. Okay. There's a better approach. Instead of having two different deletion mechanisms, let me simplify this by using the use event deletion hook properly. Yes, please use hooks properly. And removing the delete event method from the event view model. I don't know. I don't know if that's proper. Here's another opinion that I have that it doesn't know about. I have a strong opinion about how custom hooks are supposed to be used, especially in a Jinaga application. So it might be seeing my opinion all over the code and saying, well, that disagrees with the generally held best practices for custom hooks, and so I'm going to do it this way. So I need to write a hook, write a command, write a rule, a mode to teach it that opinion. Okay, so LaunchKings admin and npm run dev. So this is going to run it in develop mode and see if it compiles, see if it works. So it just opened on port 3000, and now it is probably going to, I'll proceed while running, it's probably going to open up a browser and try to click on it. It's not at it's not at 5173. Check the port number. You know what, this isn't going to work. It can't. Yeah, it's not going to be able to do this. Let's see what's going to happen when it tries. So we've gone to 3000 and nothing is working. We've just got a console error. Client ID must be set in auth config. Yeah, because I haven't set the admin application up for local use. So that's not going to work. It is not going to work. Use npm run build container to deploy to the container. So let's kill that. It's gone. And then we're going to do npm run build container, which will tell it, first of all, does it build? And so if there are any errors, then it will see the errors and it will have a chance to fix the errors. But then once it deploys, it won't be able to log in because that is protected by the FusionAuth login. But yeah, it's happy with that. Okay, we got that. But I am curious what happened here. So this now is the new version of the application. Let's refresh. Boom. And we get a forbidden. Haha. Nice. So we get a forbidden because we tried to execute this specification and failed to do so. We are not permitted to run the specification. That's what a distribution rule is all about. So it didn't update the distribution rules, or at least it didn't rebuild them. So let's see what is let's see what has changed here. So we don't have any changes to the compiled distribution rules. We have a new distribution rule here that says I'm going to share event deletion with the tenant administrators is probably what it says. Because yeah, administrator users of tenant, and share event restoration facts with the tenant administrators. Okay, so that's why you don't want to let it write those distribution rules to begin with. It thinks that distribution rules mean one thing when they actually mean another thing. We're not sharing the deletion facts. We're sharing the ability to run this specification. The user interface is not likely to run this specification. So starting from a tenant, it's looking for all of the event deletes inside of that tenant. That's not really what the specification is going to do. The specification is going to run, in fact, we can see right here, it's going to look for all of the events in the tenant where there does not exist an event delete. So that's a different specification. That's the specification that's necessary for this user interface, but that's not the one that it wrote. So, so I believe that it has gotten a little off track. Let's see how far it thinks it is. So it's got the custom hooks. It could simply be that it is off track on the distribution rules, and then we can undo the distribution rules that it wrote and create the correct ones. Or it might have gone off track on the custom hooks themselves. We will have to figure that out. But yeah, it's still working on phase 1. So it probably would have been better for me to say just do phase 1, and then we could have put things on the right track and then moved on to phase 2. So I think I am going to let's see, examine. I think I'm going to let it finish up this last task in phase 1 and then cancel it. So now it's examining all of the hooks that were created. It's looking at the snack bar component. It's creating a use event restore hook following the existing patterns. Okay, so yeah, you can see that it's going with generally accepted best practices. It's got a state pattern. I call them view models, and I've got slightly different opinions about what goes into a view model. But it doesn't know those opinions, and it doesn't know that I like to call them view models. So yeah, like right here, it's brought in restore event as a function from the custom hook. And I like to have those be functions on the view model. So that's a difference of opinion that it doesn't know about. Okay, now it's trying to build. Let's go ahead and let it run the build. Good luck. And see if it made any mistakes. Okay. There are many TypeScript errors, but most of them are unrelated to my change. Are you sure? There were no TypeScript errors before. Okay, this seems to me that it has definitely gotten off track. So I'll let it check those errors. Okay, so let's just kill it. Yeah, I want to just cancel, terminate, cancel, terminate. Yeah, I had to do that because it was inside of a subtask. So I canceled the current operation on the subtask, terminated the subtask, that popped back out to the main task, the orchestrator, and then did the same thing there. Now it's all done. I still have them in history. I can still go back and see what happened there. But yeah, there we go. Spent about $1, and then I'll take a look at what that dollar has bought me. So that is a quick peek of what it generally looks like to maintain a Jinaga application. So we are talking about defining new facts. We're talking about creating those facts, creating specifications in order to update the user interface given those facts. So I want to point out that one of the things that you saw here is all of this is done on the user interface, and then we build those rules and we send them to the replicator to be executed. In fact, let me do more than just say that. I want to show that. So we are here inside of the admin. I'm going to come back out and I'm going to go to LaunchKings model, and I'm going to npm run generate policies. And so what this is going to do is it's going to compile the authorization and distribution rules into this policy file. And so we can see all of these policies. So these are the brand new distribution rules that it created, where I want to share the event and event delete with the administrator users. So it compiled that into a Jinaga specification, into a factual specification. And then here, let's share event delete, event restore with those tenants. So these are the wrong distribution rules, but I'll fix those. The important thing here is this is just a file, and I have dropped this file into the front-end policies folder. So this is inside of the mounted folder in the Docker container. So without rebuilding the replicator, it's just the off-the-shelf replicator. I can change the rules by which the replicator is authorizing and distributing facts. So that's that's one of the key advantages. I'm just working client-side, getting everything working, and deploying to off-the-shelf infrastructure components. I'm not building a server-side API. I'm not building a BFF. I'm not deploying a brand new database schema. I'm not migrating the data at all. I'm able to focus on making sure this application works, and it's still secure and scalable while I do that. So I get all those benefits. All right, so I'll continue working on this, get this ready for CodeLaunch LATAM, and yeah, next week I will be out. So tune in for the third episode in the AI-assisted software development series that I'm in which I'm building the Game Hub application, building a game in Jinaga. So come on back for that, and I will see you on the other side. Take care.